Hey everyone, so we have some notes, and these notes should look familiar because we've actually talked about this before. Hopefully the second time around you'll get more comfortable with dealing with these and solving equations and problems with these. Okay, so the first one we had was complementary angles. Remember, that's just two angles whose sum equals 180. So like here's two different angles. This one's 60 degrees, this one's 30 degrees, and it equals 90. Okay? And the two angles do not have to be adjacent angles or stuck together like this. Here's an example of adjacent angles where the two angles equal 90 degrees. And even though it doesn't say in here what B and A equals, because it's in this right angle, I know they equal 90 degrees, right? B and A added up together equal 90. And then a different one we've talked about, supplementary angles. That's when two angles, that's when the measure of two angles equals 180 when you add them, okay? Two angles whose sum is 180, more simply put. And again, on here, again, I didn't put what angle measure P and N are, but because it's a linear pair, and that's something else we're going to go over today, or revisit, but because it's a linear pair, right, I know those two together equal 180 degrees. Okay, so that's supplementary. And that's also the next thing we're going to talk about, linear pairs. So these were the last two things, and they were on our test, chapter 1 test, I believe. Identifying linear pairs and vertical angles. Okay, so some of you guys got it, others didn't get it. Now's the chance to get it. Okay, so here says two angles whose sides form a line. So imagine, now I'm going to draw this separately. I didn't have it drawn because I wanted you guys to see. So here's one angle, and I'm going to name it the three, using three letters. M, I don't know, let's call this guy Q and P. So that's angle M, Q, and P. Okay. Now, in order for the other angle to be a linear pair with this one, it has to be it has to share a certain line or a certain side. So let's say it's going to share this side. And then two, it has to make a straight line. Okay, so here's our straight line. And the blue angle, let's call this N. The blue angle is NQM. Okay, and then those two angles together, angle NQM and angle MQP, they form a linear pair, right? And then together they equal 180 like this guy up here, but that's something else. So here we have, the next one is vertical angles. Again, some students struggled with this, but hopefully the way I draw it out today, you won't struggle with it, but well, let's go over it and see what happens. So again, one thing I mentioned to students when they were in tutoring with me the other day is you got to think of angles as V-shaped. Right? Angles are V-shaped. Okay. RST. So here's an angle RST, that's an S. Right? Let me draw it in here. Angle RST. Okay, again, think of it as V-shaped. Now, the orientation can change, like it can shift, but again, think V-shaped, and then the names just kind of go, from one end to the one end of the angle to the vertex to the other end. Okay. Now, vertical angles, I mean, those are two angles whose sides form opposite rays. So if I drew another angle coming down this way, see, this is an opposite ray, and then this one's an opposite ray. Okay, so these two angles, so this angle would be, let me call it W and X here. WSX. WSX. So these two angles form vertical angles, right? And really, again, we're talking about this angle in here and this angle in here. I think I confused some students, some of you guys, when I said it's two straight lines, because then when you name them RSX, you kind of name them going straight across. You got to remember the angles are V-shaped, okay? So again, this angle goes down and it comes back up. Same thing with this one goes up and it comes back down. So hopefully that kind of makes sense, or you kind of remember it from before. And then another thing, linear pair I put in here, they're supplementary. What does that mean? It means when you add them up, it equals 180. And the other thing I put in here, these angles, vertical angles, are congruent. Well, what does it mean? It means they have equal measures. Okay. So let's do some examples. If you need, I moved that kind of quick, but if you need to pause it to copy it. So let's look at the example here. So again, pause it right now, that way you can copy it, and then I'm just going to get into solving this. So again, you have to recognize vertical angles. So 125, this angle and this angle are vertical angles. Okay, and that means they're equal. So the angle B is 125, right? And then you gotta also recognize like vertical or linear pair angles. So let's say if I cover that up, see how this is a line here, and then these two angles, the 125 and then angle C, make a linear pair. That means they equal 180. So if I want to figure out what C is, I take 180 and subtract 125, and I believe that's 55. Let me go ahead and knock that out in the calculator. Yep, 55. So I know C is 55, and then C and A are vertical angles, so those two are equal. Pretty straightforward. We've done these before. We had a whole page, I think 2 pages of them. Hopefully you remember. And then in the next one, the next one's a bit tricky. We haven't seen one like this, but I've gone over all the information you need to solve this. Okay. First of all, if you notice, these two angles have the same mark. Because they have the same mark, it means they're equal. So if I could figure out what one of them is equal, if I could figure out the measure of one of them, I know they'll both be that same measure. Okay. So here, this here is 112, and then these two angles are vertical angles. And because they're vertical angles, I know this side equals 112. And because this angle has the same mark as this angle, I know these two angles are the same. And then if you look at just this part then looks like this guy. These two are vertical angles, so I know B is also 112, right? A and 112 make a linear pair, right? If you cover that up, see how it makes a line? So if I want to figure out what the measure of A is, I do 180 minus 112, right? And that is going to be 180 minus 112, 68 degrees. So I know this guy is 68, and then C is also 68 because these are vertical angles. And there you go. Okay. So again, if you need to pause this to copy this down, do that. If you need to rewind it to make sense of it, do that. Okay, or to hear it again, go ahead and rewind it. I have one last example, and then we'll be finished. So 3, even though you may not think of it, 3 does look like 1, and it does look like 2, like that one. Only this one is like more algebraic, or there's more algebra involved to solve this. So again, this angle and this angle are vertical angles. And because they're vertical angles, I know they're equal. So I can set them equal. 112 equals 4x minus 16. And then I just need to solve that equation to figure out what the value of x is. Add 16 to both sides. That goes away. 4x equals 128. Divide both sides by 4, and you get x equals 32. And that's what x equals, right? 32. And then to figure out what the next one is, or what the measure of AOC is, it's helpful to find out if you know where AOC is, or which angle it is. Well, AOC, see, here's AOC. So that's this angle right here, right? Again, remember, think of the V-shaped. Well, I know this angle. Let me cover this side up. Sometimes it's helpful to cover stuff up. I know these two angles make a linear pair. See how it makes one line? So these two together must equal 180. So I can do this. 180 minus 112 will give me this measure. Okay, and when you subtract those, I believe it's 68. So this guy is 68 degrees. And then again, these two are vertical angles. So that's DOB. DOB. That's also 68 degrees. And that's it. Pause this to copy it, rewind it if you need to hear it again. We'll do some work.